My problem is about linear momentum, and in this situation, a rubber ball of mass 50 grams is being thrown towards a vertical wall. It will strike the wall at a horizontal speed of 20 meters per second and bounce back with a horizontal speed of 18 meters per second, as shown in the diagram. The ball is in contact with the wall for 0.080 seconds. The question asks that we define linear momentum and impulse. Momentum is just the product of the mass and velocity, displayed in this equation P equals mv, and impulse is the change in momentum of the body being acted on by the force, or impulse equals force times the change in time. Both of these equations are vector quantities. In order to solve the equation, we will need to first find the change in momentum. To find the change in momentum, we will need to find the momentum before the collision and then the momentum after the collision. Before the collision, the momentum of the ball is 1 Newton per second, as shown in the diagram. And then after the collision, the momentum of the ball is 0.9 newtons per second. But both these quantities, as we said earlier, are vector quantities, and so the momentum after the collision will be acting in the opposite direction. So when we're finding the change in momentum, when we subtract the momentum before the collision from the momentum after the collision, they will actually add, and the change in momentum will come out to be 1.9 newtons per second. The next part of the question asks that we find the average force exerted by the ball on the wall. In order to do this, we need to use the equation impulse equals force times change in time. Through a little manipulation, we can then make it into force equals the change in momentum over the change in time. From the previous question, we found that the change in momentum was 1.9 newtons per second, and it is given that the collision time is 0.08 seconds, and we can then plug this into the equation, and it turns out that the average force exerted was 23.75 newtons. The next part of the question asks that we replace the rubber ball with a steel ball of the same mass and the same initial horizontal speed to determine what would happen. As it turns out, the steel ball is actually inelastic and would have a much smaller collision time than the rubber ball. Thus, the rate of change of momentum would be greater because the change in time is reduced in the impulse equation. And there you go. That's how you solve the problem on linear momentum.